Hello everyone, welcome back to Chemical Engineering Enhancement channel. In our today's video, we will focus on the subject of heat transfer operations, and in this regard, we are bringing the lecture number 11 for our valuable viewers. In our previous lectures, we have studied the difference between the thermodynamics and heat transfer. We have studied the various types of heat transfer including convection, conduction, and radiation, and we have studied their respective laws related to these three phenomena, which are Fourier's law of heat conduction, Newton's law of cooling, or Kirchhoff's law of radiation. So we have studied these laws previously, and we have solved various examples related to these phenomena. In our today's lecture, we will go to the heat exchangers, and it is an important part once we talk about the heat transfer operations. First, we will study the introduction of heat transfer. Then we will see the various types, but today our focus will be on the first type of heat exchanger, that is the double pipe heat exchanger. And this is the diagram which I have picked from the literature, and I will be presenting this diagram to you thanks to the owner who has actually created this diagram. So before starting the lecture, if you have not subscribed to the channel yet, please subscribe to the channel. Click on the bell icon to get all updates related to this channel. So in heat transfer introduction, first thing which we will talk about is that there are basically two fluids. One of them is the hot fluid and one of them is the cold fluid. It has to facilitate these two fluids which are at different temperatures while keeping them away from mixing with each other. So basically there are two fluids. One of them is hot fluid. The definition of hot fluid is that it is at the high temperature, and during the heat exchange process, it will lose heat, its temperature will drop. On the other hand, the heat will be transferred to the cold fluid whose initial temperature is lower, and with the heat exchange, it will gain heat and its final temperature will be higher. Commonly used in practice in a wide range of applications, once we talk about the heat exchangers, from heating and air conditioning system in a household, which is a very typical example. Once we talk about the heaters in the house, or air conditioners, ACs in the house, or air coolers in the house. So it is very much important aspect of heat exchange in daily life, to chemical processing and power production in large plants. If we talk about the boiler system, turbine system, or condenser system, the heat exchangers play a vital role over there. Heat exchangers differ from mixing chambers in such a way that they do not allow the mixing of these two fluids. In the mixing chambers, the both fluids mix, while in heat exchangers, both are separated by a boundary wall, or you can say if there are two pipes in a system, one of the fluid will flow through one pipe and the second one through the other pipe or the annulus of that pipe. So this is the overall introduction or the first part of introduction of heat exchangers. Heat transfer basically involves in heat exchangers involves convection in each fluid and conduction through the wall separating the two fluids. So first one is the bulk motion and then the heat transfer between the solid and the liquid. And since both these fluids are not mixed, so there is always a separate wall or a boundary wall that is separating them. In the analysis of heat exchangers, the overall heat transfer coefficient, that is the U, which was studied during the heat convection phenomena, is very much important. That accounts for the contribution of all these effects on heat transfer. So this is an important aspect once we talk about or once we go to the numericals in heat transfer problems or heat exchangers problems. The rate of heat transfer between the two fluids at a location in a heat exchanger depends on the magnitude of temperature difference at that location, which varies along the length of the exchanger. Let me show you that if we say like this, that the cold fluid is coming here and hot fluid is going here, then at this point, the temperature difference between the hot and cold at this point, at this point, at this point. So at each point, the magnitude of temperature difference will decide or will dictate the rate of heat transfer. More the temperature difference, more will be the heat transfer. We have already studied that in our previous lectures. This is the overall introduction of heat exchangers in our today's lecture. Now going to the type of heat exchanger, the most common types, obviously there are multiple types which we'll be studying. But the most common type is the double pipe heat exchanger. If we talk about the double pipe heat exchanger, the one fluid that flows through the smaller pipe, while the other fluid flows through the annular space between these two pipes. Before going further to the flow arrangements, let us see this pictorial representation of double pipe heat exchanger, that the steam or hot fluid that flows through here. Now this is the two pipe. If we just look at this part, this is the inner tube or inner pipe through which the cold fluid will be flowing, and this is the outer tube or the outer pipe through which, or we can call it as the shell side. The inner pipe we can call it as tube side, the outer pipe we can call it as shell side. So the hot fluid comes here, hot fluid passes through here, the cold fluid comes through here, and cold fluid passes through here. So this is the one pass, this is the second pass, and this is the third pass of double pipe heat exchanger. If we simply specify that the cold fluid is passing through this pipe, the inner pipe, and then going out as the much or going out at a much higher temperature, while the hot fluid is coming through here, flowing through this annular space between the pipes and then leaving out as a condensate. Obviously, there cannot be a temperature cross, which we will be studying in our upcoming lectures. So this is the overall pictorial representation that the cold fluid passes through the inner pipe while the hot fluid passes through the outer pipe. Obviously, the arrangements may vary in different applications. Now coming back to the flow arrangements, there are two types of flow arrangements which are commonly used in this system: parallel flow and counterflow. Parallel flow means that both hot and cold fluid flows in the same direction, while counterflow means that if this is the side, this is the direction of hot fluid, the cold fluid will flow oppositely. So in parallel flow, both hot and cold fluids enter the heat exchanger at the same end and move in the same direction. While in counterflow, hot and cold fluids enter the heat exchanger at opposite ends and flow in the opposite direction. So this is the flow arrangement in double pipe heat exchanger. Now again, looking at the temperature profile, or looking here, that in parallel flow, you can see that the cold fluid is entering from the same side as that of the hot fluid, and exit side is also the same. So this is the temperature profile for these fluid, that the hot fluid temperature is dropping while the cold fluid temperature is increasing. Now, this cold fluid temperature cannot cross the hot fluid because it will be a temperature cross mathematically or physically impossible to achieve, or practically impossible to achieve. So there will always be a delta T between these two. While in this counterflow, the hot fluid is entering from this side while the cold fluid is entering from the opposite side. And again, the discharge or the outlet is also from opposite side. In this case, this is the temperature profile for hot fluid, while this is the temperature profile for cold fluid. The cold fluid temperature is increasing, the hot fluid temperature is decreasing. Once we go to our next lectures, we will study in detail about the delta T here, the significance of delta T on heat transfer, which of the condition or which of the combination is better, we will study in our upcoming lectures. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video, and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.